Okay, good morning class. Good morning class. So today we're looking at trigonometry. We have just finished the exercise dealing with the area rule. So today we're going to look at the examples dealing the examples for exercise 10.3. And 10.3, exercise 10.3 is on page 343. Okay. So solving triangles that are not right angle. So if it's a right angle triangle, I can use sine cos tan, or I could use the area rule, which is half base times height. So let's read what they say here. To calculate the length of sides and the sizes of angles of triangles that are not right angle, we will use one of two rules depending on the given information. These rules are called, in the first case, the sine rule, or in the second case, the cosine rule. So today, we will be looking at the sine rule. Okay. Sine rule. So the sine rule, that's your subheading. Let us look again at the formula for the area of a non-right angle triangle. So we just came out of this now, this exercise, okay? Where we know that the area of triangle, if you are given angle A, it's going to be half BC sine A. If we're looking at the same triangle, okay? So this is half, the area is going to be half, but now that angle is going to be AB sine, sorry, this is going to be C, no? So it's going to be BC sine A. Not so. If we knew this angle, it would have been half AC sine B. But if we had this angle here, it would have been half AB sine C. But if I had the information for this here, for the angle A and that there, and I worked out the area, would that area have been the same or different if I had this information? Same. Why? The same triangle. What if I had that information there? Will also be the same, because it's the same triangle. You with me, Zosie? You see, what I'm saying is, if I had this information here, if I had all the information of this, I had the length of A, B, and C, I got angle A, angle B, and angle C. I got everything of that triangle. And I worked out the area using this angle A, length B, and C. My question was, is that going to be the same, the area of that triangle, as if I had the area, the angle B, the length A and C? And the answer is yes. Why? Because it is exactly the same triangle. So since we are saying it's the same, so they are all equal. So what I'm going to do is I'm going to take this whole story and multiply this by 2. Why do you think I'm multiplying it by 2? Get rid of the fraction. Not so? So all of that falls away. So in other words, we have BC sine A equals AC sine of B equals AB sine of C. So let's see what happens if I divide the whole story by ABC. So I'm going to have this over ABC, that over ABC, that over ABC. What happens? That cancels. What am I left with? Sine of A over A is equal to sine of B over B, which is equal to sine of 0. And this is now the sine rule. Okay. Write that down. This here. And sine of A over A is equal to sine of B over B, which is equal to sine of C over C. Now, people, if I am 1 over 2 is equal to 5 over 10. And I swap this around. It becomes 2 over 1. But 2 over 1 is now equal to what? 2. 2 over 1 is also equal to? So if I swap that fraction around, take the reciprocal on one side, and I do it the other side, it remains the same. Which means to say that this here could also be written as A over sine A is equal to B over sine B, which is equal to C over. Okay. It's the same answer here. So say for argument's sake, you want to calculate an angle, and I use that formula. Why? Because then the unknown is on top. If I want to calculate the unknown side, then I use this one. Why? Because the length is on top. Can you see that, people? But when I do it, I just use the one in blue. Okay. The reason for that is because at this point we are, what's the name, enough to manipulate the formula, to change it. Okay, so if you use this one and you want to calculate an angle, you'll get the same answer provided you made no mistakes. Likewise, if you want to calculate a length and use this formula, you should get the same answer provided you made no mistakes. Okay. Any other questions? So let's read what they said. They said, okay. So again, the area here, since, whoops, we are told, since there are 3 different formulas for the area of the same triangle, the 3 equations can be combined as follows. Why can it be combined? Because the areas are the same. So we're going to multiply throughout by 2. I then get BC sine A is equal to AC sine B is equal to AB sine C. Divide throughout by ABC. We then get sine A over A is equal to sine B over B, which is equal to sine C over C. This is called the sine rule. We will apply the sine rule when we are given. So the sine rule we will apply when given the length of one side and the size of 2 angles of a triangle. So you have a side and 2 angles. Okay, so just draw it. They give you a picture. 2 angles and a side. Any side, we'll use the sine rule. You guys understand? Okay. So that point, you can make a point of that thing. We will apply the sine rule when we are given the length of the side of the length of one side and the size of 2 angles, or we are given the length of 2 sides, and the size of a non-included angle. So side angle. Either that angle is given or that angle is given. You just make a diagram there on the side so that you know what you have. Where would you be using what? Alright. Now carry on. Alright. We got the sine rule. We have made this note now already. The sine rule in any triangle ABC, sine of A over A is equal to sine of B over B is equal to sine of C over C. Or A over sine A is equal to B over sine B is equal to C over sine C. Okay. But you can't say sine A over A is equal to B over sine B. No. That is not right. Okay. So if you go sines on top, it must go throughout on top. Can you see that, people? So here, we're given triangle ABC, and as you can see, opposite vertex B is lowercase b, lowercase c is opposite vertex C, and so on. Okay? So in using sine of A over A, when you want to calculate the size of an angle, then we normally go with that one. But you want to calculate the length of a side, we normally go with this one. But what did I say earlier on? You will see me interchange. I would use this one all the time. Okay? Why? Because I've been strong enough to do manipulation of formula. Okay. So in using the sine rule, you need to have at least one angle and the side opposite that given angle. Okay. So you must at least have one side opposite the known angle. So it's if we got a B, we need to know what the length of B is. So there must be one how can you say, one pair, okay, one angle and the opposite side. One of that you must have one pair of those, okay, to calculate the missing part. So coming back to this here, so remember what did they say? Must have two lengths and a non-included triangle. So if it's A, B, C, lowercase a, lowercase b, lowercase c, and I had an included angle. So if we take what we have, so say for argument's sake, that was it, and we had to take what we have, then it's going to be, we have angle A, we don't have lowercase a, we got lowercase b, and we got lowercase c. And you see the, so these, if I close that, I have two unknowns. If I close that one, I have two unknowns. If I close that, I have two unknowns. Can you see that, people? Whereas if this is a non-included angle, so in other words, we have angle B instead of angle A. Can you see that? So in other words, we can actually, what can we calculate here? We can calculate C. Why? So if I cover that up, there's one unknown. You guys understand? But you'll see it in practice shortly, okay? Right. Then, when you are given two sides and a non-included angle of a triangle, start by calculating the angle opposite one of the given sides. Okay, the angle opposite one of the given sides there. And then when you are given two angles two angles and one side of the triangle, start by calculating the third angle by using sum of triangles. If you got two angles, you can work the third one out by using sum of triangles, then calculate the unknown side opposite one of the given angles. Okay. Okay, so that brings us to the end of our introduction to 10. Okay.